On this example, we're given the graph of a function, and we're asked for intervals where it's increasing, intervals where it's decreasing, and then the inflection point. All right, so as we take a look at it, we want to kind of visualize it's going to be increasing if we're walking on top of the graph, moving from left to right. If we're going uphill, we consider that to be increasing. If we're going downhill as we walk on top of this, that's decreasing. So let's try to make these into intervals. Now, as you can see on our graph, it appears that it keeps going down forever on this side and keeps going up forever on the right-hand side. So visualize it as though when it goes off the graph paper, there are arrows that it continues that same behavior forever. So I would say as I'm beginning on the left-hand side, we would say we are increasing, we're going uphill on this side. So that's going to begin our increasing interval from negative infinity. Remember, this is an x value. So way off to the left-hand side is a negative infinity for an x value. And it looks like we top out. We stop increasing at the top here, which appears to have an x value at -2. Now, intervals for increasing and decreasing are always open intervals. Because that topmost point, we can't really say if that's part of the increasing or part of the decreasing interval, so we leave it out of both intervals. That's actually where we get a local or relative maximum. All right, on the next interval, we're going down, right, as we continue our journey from left to right on this graph. So we're going to call that decreasing. Now, it begins at that topmost point at -2, which again is going to be left out, and it looks like it ends right here at the bottom where we get a local minimum. Now we're going to have to estimate that, but it looks to me like that's right between 0 and 1, so I'm going to say 1/2 for an x value. Remember, it's always x values for these intervals, not y values. Again, an open interval there. All right, continuing on our journey, we're at that lowest point, right, that local minimum, I should say. Then we're going to walk on top of this. It looks like we're going back uphill. All right, so that begins at 1/2, remember an x value. And where does it end? Well, it continues in that same motion, continues up forever. So as we continue off to the right-hand side forever, that's going to be an x value of positive infinity, we say is to the right forever. Again, also open interval as we go through this. Now, because we got two intervals for increasing, we're going to go ahead and include both of them. We're going to put a union symbol, a capital U, going in between these to say both of these are individual intervals where the function is increasing. Now, the last question we have there is about the inflection point. So when we're thinking about an inflection point on a graph, an inflection point is where we change concavity. All right, concavity, if it was concave down, it looks like the top of an umbrella. If it's concave up, it looks like the bottom of a bowl. Now, on our graph, it looks like it starts out and we're the top of an umbrella, but at some point we change and we go to the bottom of a bowl, kind of on the right-hand side. So our concavity switch is somewhere in the middle here. We want to kind of identify whereabouts do you think we make that change. And I would estimate it to be right about this point here, which I would estimate to be an x value of -1/2. Now, if we needed a y value to go with that, if we were looking for the entire point, I would say it's about -1/2, maybe 8/10 of the way up, maybe about 0.8, thereabouts, where that point is located, because we're between 0 and 1 on the y-axis, definitely closer to 1 than 0. I would guess right around 0.8. All right, so if you need an entire point, make it an ordered pair. If you only need the x value, do your best to estimate that. Our x value came because that x value is somewhere between 0 and -1. So I hope this helps out. Good luck as you're working on intervals for increasing and decreasing and identifying inflection points.